4.10 Equations of lines. So our goal here is to be able to go back and forth between the representations of a linear relation. So we have one representation in the form of an equation where you have a y value equal to an x value multiplied by m, and m here is the number or the constant that represents our slope of our line. Okay, and then we add b, and b is the value that represents our y-intercept, where the line crosses the y-axis. Okay, and the graphical form of the line can be represented by a straight line. Okay, and we can often do things like find the slope of this line by picking 2 points and measuring the rise and the run of the triangle that we create between these 2 points. Okay, and again on the graph of a line, where the line crosses this y-axis, this point right here, that is our y-intercept. So that's the visual way of looking at what the y-intercept looks like. And if we do rise over run, we can also find our slope. So our slope is equal to the rise over the run. Okay. In a table form of a linear relation, again, if you're looking for the slope, we're looking at the change in the y value, so the rise over the run. So the change in the y values is our rise, because this line here represents going from this y value all the way up to that y value, right? Okay, so the change in our y values here is from 5 to 2 is a drop of 3, so the rise is minus 3. And to go from -2 to -1, that's a run. The x values, now the change in our x values is the run. And so that is a value change of +1. We're going up by 1 if we go from -2 all the way to -1. Okay, so we can find our slope by doing -3 over 1 in this particular case of a table of values. And we can also find our y-intercept. Okay, so the y-intercept not only is where the line crosses the y-axis, but the x value is also 0. So the x is 0. Like here on the graph, x is 0. There's 0 here. Okay, so x is 0, and the y value would be our y-intercept, -1. So this is the y-intercept when x equals 0. Okay, so to go back and forth between the different representations of a line, you just have to be able to identify how to find the slope and how to find the y-intercept. Okay, so remember that you always need to determine the slope and the y-intercept. Let's look at some more examples. So here's my equation to graph 3x minus 5. So 3 is going to tell me what my slope is, and the minus 5 is going to tell me what my y-intercept is. So when I go to my graph, I'm going to look for that y-intercept. That y-intercept here is -5, okay? And so that's my first starting point. So number 1, how did I graph this? Start by plotting the point at the y-intercept. Step 2, using slope. The slope is 3, so the rise could be 3 and the run could be 1. 3 over 1 is 3, right? So a positive value means we go up. A positive value in the denominator means we go to the right. Okay? So from the y-intercept point, we go up 3 over right 1. Okay, and then you repeat for multiple points. Okay, so let's go to our graph. We're going to go up 3, so here 1, 2, 3, then right 1. There we plot our next point. And we go up 3, so 1, 2, 3, and then right 1. There's our next point. Up 3, follow the red dot, 1, 2, 3, then right 1. There's our next point. Okay, and then we can connect those points to make our straight line. So let's just draw a line. Here we go. And we can extend our line to continue showing that there's a linear relation here. Okay, and I just put arrows on both ends to show that the line continues in both directions. Okay. All right, so that's going from an equation to a graph. What about a graph to an equation? Okay, let's look for our y-intercept here. So the y-intercept is equal to positive 3. Okay, so in our and then our slope, we need our slope. Let's pick another point we can read. I can read this point down here. So we can create a triangle. So just measuring the rise over here and then the run over here. Okay, so how much of a rise do we have? So to help me find my slope, I'm going to find the rise. So the rise goes from this value of 3 all the way down to 0. Okay, so that's a drop of 3, so minus 3. And then from left to right along the horizontal, I go from 0 all the way to 6. So that's a run of 6. So negative 3 over 6 is my slope. In the lowest terms, I'm going to write that as negative 1 over 2. So my equation is going to be y equals my slope, negative 1 over 2, multiplied by x, and then add my y-intercept. So y-intercept is positive 3, so it's going to be plus 3. And there's my equation. Okay, what about, let's go to our next page, table of graphs, table of values to a graph. Okay, so here we have to look for, let's look for our slope. Let's look at our change in y values and change in x values. So go from 0 to 2, that's an increase of 2. To go from negative 2 to negative 1, that's an increase of 1. So my slope is going to be the rise over run. So slope is the rise, the change in y values, 2, over the run, change in x values, it's 1. Okay, so 2 over 1 is simplified to 2. What about our y-intercept? Right here, x equals 0. So the y-intercept is going to be the y value. So y-intercept is equal to 4. So on my graph, look for 4, plot that y-intercept. Slope is 2 over 1, so go up 2, 1, 2, over to the right 1. There you go. Put the next point. Up 2, over 1. There you go. You can even go in reverse. Okay, plot the points on the left side as well. Okay, and then connect your points with a straight line. You can continue the line in both directions. Make sure you draw the arrows at the endpoints to indicate that the line continues on forever in both directions. Okay, what about the graph to the table? So here at this point, you're just starting to look for key points. So let's say y-intercept is here, 0 and 2. And one point we want to put, we'll put in the middle of the graph, middle of the table, I should say. Okay. So what's our slope? Well, here's another point I can read. Okay, negative 1 and negative 2. So what's this rise? To go from positive 2 to negative 2? Well, that's a rise of 4. What about here 0 to negative 1? That's a run of 1. Okay, so again, all you have to do really is just plot other points that you can read. So I can here read negative 1 and negative 2. And I can also read negative. So down here I have negative 2 and negative 6 approximately. Okay, and then here 1 and 6, and then 2 and 10. Okay, so here 1 and 6, 2 and 10, negative 2 and negative 6. Okay, and then you can just check, yes, negative 6 and negative 2, it's a rise of 4. Negative 2 and negative 1 is a rise of 1, so the slope works. Okay, the slope is 4. My y-intercept is 2. Okay, table to equation. Table to equation. All right, so for an equation, we just need the slope and the y-intercept. So what's our slope? The rise is 5 to 8, so that's 3. 1 to 2 is a rise of 1, so the slope is 3. So 3 over 1, which is 3. Okay. What about our y-intercept? Well, I don't see an x equals 0, but if I work backwards, so 1 to 0 is just a decrease of 1. I'll decrease this 5 by 3. So if I go backwards, it's going to be 5 minus 3, which is 2. So my y-intercept is going to be 2. Okay, so again, the difference between 2 and 5 should be 3. The difference between 1 and 0 should be 1. Right, this is all 3. This is 3. This is 1. This is 1. For a line, they should all be the same. So for my equation, I'm going to have y equals 3x because my slope is 3. And my y-intercept is 2, so I put plus 2. Equation to table, start with the starting value 10, so 0 and 10, that's my y-intercept, right? What's my slope? Minus 3, so I have to decrease this value by 3 every time, so negative 7, Sorry, not 7. Sorry, 10 minus 3 is 7. 7 minus 3 is 4. 4 minus 3 is 1. Okay, then I just increase my x values by 1. So 1, 2, and 3. Okay. So I just make a note here. This is my y-intercept starting value. Okay. Or what you can do is pick x values and substitute them into the equation. So if you pick x equals 1, so sub equal x equals 1, for example, then you can do y equals negative 3 times 1 plus 10. So negative 3 times 1 is negative 3 plus 10. So that gives you 7, right? So equals 7. The 10 take away 3 is 7. Exactly what we have up here. So you can do it a couple of ways of doing this. All right, so some special lines before we end this lesson. So what's happening here? All the x values you have, no matter what x value you have, here at negative 3, you can take a 0, or positive 3, you have the same y values. At negative 3, you have the y value of 6. Here at 0, you have a y value of 6. Positive 3, the y value of 6. Oh, y equals 6. No matter what x value you pick, y equals 6. Right? So y equals 6 is my equation. That's the equation. There's no x in this equation because x is everywhere. X is everywhere. No matter what x value you pick, y will always equal 6. And so y values always 6. The slope is 0. Okay, it's horizontal line. For vertical lines is different. Okay, the x value is only going to be negative 4. There's no other x value anywhere else, right? Like 6. If I pick 6, wait, there's no graph. There's no graph here. So the x value has to be negative 4. So negative 4, negative 4, negative 4. What's the y value? Well, any y value exists on this line. So if I pick this y value, it's there. It's going to be 5, right? So 5. 0 exists there as well. So 0. Minus 2 exists there as well. So minus 2. So any y value exists on this line, but the only x value is negative 4. Okay, so x equals negative 4. That's the equation. Now you can have an equation of a line by saying x equals negative 4. You don't have a y in here because the y value, any y value works. Right? So x values always negative 4. The slope is undefined, and we talked about this in the previous lesson. The slope is undefined, no slope. Okay, it's like an infinite steepness slope. All right, so those are our special cases, and that ends this lesson.